Welcome to the SPE podcast, powered by the Society of Petroleum Engineers. You're listening to SPE Live, Natural Language Processing in the Subsurface and Wells Disciplines. The audio from this episode was previously recorded on April 26, 2023. And now your moderator, Claude Boudoir.
Hello and welcome to this edition of SPE Live on the topic of natural language processing in the Subsurface and Wells Discipline. My name is Claude Boudoir. I am an independent consultant in information technology and knowledge management based near San Francisco, and I'm a member of the SPE Data Science and Engineering Analytics Technical Section, DSEA TS, and I will be the moderator today. This SPE live session will last 30 minutes, and we can take your questions mostly at the end, but feel free to ask questions anytime during the program. If there are clarification questions, we'll try to answer them immediately. When the new DSEA Technical Section was created last year by merging two other sections, we started planning a newsletter series, and the first of those appeared on December 1st, 2022. They're quarterly. The first article of substance in that inaugural issue in December was written by Paul Cleverley, so he had the privilege of being our first author. And he wrote this article whose title was Natural Language Processing in the Subsurface and Wells Disciplines. This article was really a very elaborate 13-page paper with figures and references on this topic of how you can use natural language processing to improve a lot of the work that's being done in the oil and gas industry. So naturally, we wanted to feature Paul in one of these SPE Lives and dig deeper into his knowledge of how this particular aspect of artificial intelligence applies to oil and gas, and that's what we aim to do today. So it's now my pleasure to introduce to you our guest. Dr. Paul Cleverley is a geoscientist and a computer scientist by background. He has worked for numerous companies in the IT and energy sectors for the past 30 years. He's based in Oxford in the United Kingdom. He founded a disruptive tech startup, InfoScience Technologies Limited, in 2018, pioneering the use of natural language processing algorithms for the subsurface and georesource sectors. He also has several unpaid roles, including serving as visiting professor of information science and university at RGU, Robert Gordon University in Aberdeen in Scotland. Dr. Cleverley, welcome to this SPE Live.
Thank you, Claude, and good morning, afternoon, everybody.
So I would like to start with basically a background explanation on your part, because some people may not be familiar with, the definition or the scope of natural language processing and why it seems to have recently gained so much popularity. Can you please start with that?
Sure. Well, natural language processing, or NLP for short, it's a branch of artificial intelligence concerned with how computers understand human language through voice or the written word. I like to think it's the process of turning unstructured information into structured information. You can think of NLP as mainly split into two, really. One is statistics, so word patterns are learned from text. And secondly, methods based on linguistics, so rules, representations of knowledge like taxonomies. And many real-world business problems often require both of these techniques to be used, and value is often at the interfaces between many different techniques, some of which we'll discuss today. I mean, we all use NLP. We use our email. If we perform a Google searches, we talk to our conversational assistants like Alexa. NLP is almost omnipresent in a lot of things that we do in the digital world. It's trying to understand the intent of what a person is asking. There's natural language understanding, which is very much about understanding that intent, whether you type in something to Google or you ask Alexa. There's natural language generation. We've heard a lot about things like ChatGPT, models that sort of generate new text, which you may have seen if you've ever played AI Dungeon, which is a text adventure game, again with a model like that behind it. from an organizational oil and gas point of view, I think there's been a growing realization for companies that there are insights locked in their unstructured text on their file systems in their archives, which are not in structured databases. There's too much for us to read ourselves. We need machines to try and help us to automate tasks, extract data, summarize information for us, and also detect patterns and anomalies. And if you combine this with recent advances in compute power, algorithms, open source algorithms, some of the deep learning models that you see, there are things. I mean, when I was asked to write the article for SPE, Chat GPT hadn't even been launched. So, I mean, there are things in NLP that you can do today that you couldn't do last month, that you can do last year. It's a very fast moving pace, Claude.
And so, based on that, at what point and how did you come to appreciate the potential of this technology in our domain, and especially how it could be applied to subsurface data?
Yeah, good question. I did my PhD quite late in my career, back in 2013. I picked up Python and retaught myself programming. I'd done that when I was a bit younger. And I conducted interviews with geoscientists and engineers, video observation experiments using stimulants and prototypes to really try and find what NLP techniques people found valuable for what tasks and why. One area that emerged, really, which was perhaps poorly met, was exploratory search goals. So, if we look at a traditional search engine, you get lists of results when you type questions, or if you want an answer, such as Chat GPT. And it's great if you want a specific result. But if you're sort of exploring, asking questions like, what's the reservoir quality like in the Elysee Basin, there's not a right answer. Summaries you have to be very careful of because they might smooth out important outliers. And it could be, that piece of information on page 20 of a PDF that appears 10 pages down in your search results, which actually turns out to be the most interesting in amongst your results. But you'll never know that because you'll never read that far. So we have to be careful a little bit with these algorithms, because they become a bit of an epistemology. They're how we come to know things. They curate what we see and therefore influence what we know. So we can counteract that with NLP to take us off the beaten path and, find out some of these more interesting or unusual things in amongst the text as well as the obvious.
So following up on that, in the article you wrote, the paper you wrote for us in December, you went pretty quickly into a description of what's called transformer models, which is another phrase that a lot of people are using casually today without necessarily explaining it. But people have heard a lot more about transformer models recently because of all the news and the hype about ChatGPT. So can you briefly explain what a transformer does and how it does it? Sure.
If you allow me just to go back a little bit to some of the sort of fundamentals. I mean, Firth, back in 1957, coined this wonderful phrase, you can find a word's meaning by the company it keeps. So words that occur together or in similar contexts tend to be more closely related. So we can build a probability distribution of words as numerical vectors using some of these philosophies. So in simple terms, we can create a word vector for any word that represents the words that occur in proximity to that word from everyday training data, whether it's on the internet or our own company data. And then we can take these vectors and do things like cosine similarity between them, and the closer they are, the more similar we can infer. So words like the internet and, say, the World Wide Web will have very close cosine similarities of their vectors because the words mentioned around those are very similar. So we can use this for a range of things. I did a bit of a study on the Society of Petroleum Engineers papers itself, 70,000 of them. And if you take a word permeability, the most commonly occurring word to permeability in the SPE is relative, occurs next to it or within the same sentence. But if you look at geological literature, like the Geological Society of London, it's porosity. Also, words like fracture, very associative with permeability in the SPE. Geological, not so. It's more related to faults. So you've got these subtle elements even within different disciplines and training data. But we can use these patterns to train a model, to predict for almost any word what word follows it for a given context. And this is powerful, can be used for all sorts of things, identifying analogues for reservoir drilling, geological purposes, for example, just from the patterns in text. There may surface some analogues we hadn't considered, casting a bit of a wider net, perhaps than normal. So if you fast forward all of this to the latest computer techniques, I like to think of it as just very complex word co-occurrence on massive amounts of text. On the internet that we've all helped create, we're now indirectly teaching these statistical models to create this probabilistic model to create a relationship to some extent between all words. So the transformer model uses mathematical techniques called attention or termed attention, first described by some of the Google Brain researchers, and essentially is a deep neural network. It learns context, associating word with every other word in the sentence. So you specifically, an embedded vector containing positional information is fed to an encoder, performs some algebraic functions. The decoder output is enriched embedded vectors. A couple of things that this approach, that previous approaches haven't done, is it uses long-range dependency of words. So it's very, it can predict how even quite distant words relate to each other, has a significant context window. And these techniques also lend themselves to parallel processing. So you're seeing these models just getting bigger and bigger, using more and more training data. And then we can take these models, fine-tune them for downstream tasks, specifically for, say, summarization or for chatbots, or for translation, and so forth, and can be very useful for businesses, as many have found out.
So you mentioned in this explanation a couple of corpora of texts. You mentioned, of course, the 70,000 SPE papers. You mentioned the British Geological Society corpus of papers. What are you mentioned in your article lease abandonment reports as being a source of rich information. I can also think of drilling reports. Are there other things you've been using in your work that give you, the training data or the information you need to make the model work?
Yeah, I think, you can use these models, straight off the shelf and actually that have been trained on the internet and apply them to company content. My NLP projects tend to typically use the Office documents that companies have, PDF, Word, Excel, PowerPoint, that might be on their file systems, or results of large scanning projects or document management systems in SharePoint. Not necessarily just to build statistical models, use other techniques that we may come on to. I've done some work with emails. So, you can do lots of things with this. Obviously, you can extract data, you can detect contradictions. It's always interesting when you find contradictions in text. Of course, the basis of the research method and literature review, which we do, is in oil and gas as well, of course. For example, did some extraction on well completion reports, taking out things like proppant, volumes, duration, acid data, correlating that then with data outside of the unstructured corpus to calibrate, say, production, and then come up with improved completion design. So it's not just using just text. You can also correlate and bring in data outside of that. Probably also talking in general terms, I've been using some of my algorithms are sort of developed for things like geotagging, for example, that allow you to position documents on a map, really from scanning projects, millions of documents, bring in word sense disambiguation. So to take an example, you've got, say, a Zara. You come across a Zara, it could be someone's name, it could be a company, it could be a city. If it's a city, is it the city in Spain or Argentina? So when you're trying to really pinpoint in a laser-like way these elements, word sense disambiguation is a key part of NLP for any word which is polysemic. In other words, it has more than one meaning. So that when you have a large amount of text, that's a key element.
And that hints that various forms of knowledge representation, including ontologies and taxonomies and glossaries, etc., become really important. And you've just, I guess, explained a question I was going to ask you, which is about the importance of these things. When we look at the geoscientist or the petroleum engineer who's trying to use one of these models in order to derive new inferences, let's say, how do you interact with such of these models? Is it the kind of stuff that we've seen in the press recently about ChatGPT, where if you ask a silly question, you may get a stupid answer? Or is it what's the process of actually operating this model and making it give you some useful insight?
Sure. I mean, there are very different types of models. I mean, we may come on to graphs, but ChatGPT is a hot topic. I mean, you're going to have that real time sort of question answer aspect that's going to be quite useful for companies, whether it's on operational information or manuals, a way for people to interact with information in a much more intuitive way, perhaps than they've done in the past with pick lists or SQL-like sort of statements. So I think there might be some targeted sort of subsurface specific mechanisms for this. We also, of course, interact with the products of things like transformer models. I mean, if you've ever used Google or Bing, you're consuming the output from transformers. If you want meaningful file titles, things like look on a project and you've got things like final.pdf or 10045.pdf, we can generate meaningful titles. So there are sort of direct interaction with the model, but then also the products. We're probably also moving to more natural language type querying of structured databases and tables as well, and graphs, which is very exciting, because at the moment interacting with some of these things can be a little bit cumbersome and not tremendously exciting. Information visualization is another way, I think, to cope with all of this information. I spent quite a bit of time on this, stacking up all of the mentions of a concept of interest in text, including the outliers, the edge cases, looking at the sentiment, like the potential source rocks, by area in a geological age, or drilling problems by formation, the quality of casing that we can extract out from text, so spatially. So by clustering some of this data, we might even come across some interesting and overlooked trends. For example, taking word vectors around bleaching, carbonate cements, clay minerals, iron precipitation, maybe clustering that, plotting that against vectors for different lithologies, we could come up with potentially overlooked fluid flow pathways in a basin. So these little latent patterns hidden in all of our text that could be knowledge hiding in plain sight.
Yeah, and in your article, you did mention that some of these techniques had allowed you to discover things you did not expect, right?
Yeah, indeed. I mean, if we're talking about sort of graphs as an example. That you think of graph as being of nodes and edges, so we can store interrelationships between events, entities, concepts that don't necessarily explicitly exist. Graphs can be data driven, so unlike sort of relational database, the schema more or less reflects the NLP logic of perhaps what your Python algorithms are extracting. And we're familiar with graphs and page rank in Google around each node is a web page and an edge is a link from one page to another. Facebook, friend of a friend, whose friend of a friend plays a guitar. We can do the same with geoscience and engineering. Which wells in this area penetrated this formation with casting, these sorts of types of things. And applying to sort of geoscience and engineering discovery, we can take these mathematical graphs and in a way there's a visual representation of the the geology and engineering linked to a reservoir or a play, with the wells known to interact with that. And it might be much more fun and useful to interact with that using a chat GPT type interface to explore the different pathways and query that graph. So again, another example of taking different NLP approaches, statistical and linguistic, and putting them together for a potential solution. In terms of finding new knowledge, I've got some examples. So I've been creating sort of knowledge graphs with some of my algorithms as an instance graph rather than a reference graph. So it's important to me how many times that edge between two concepts is detected within the text. We take a simple example. As one company found there was some lower Cretaceous source rock in an area that they weren't aware of, and this is a very simple sort of technique. This particular example of, if you like, the ABC technique. So in one document there was a mention of high TOC with a rather lesser known lithostratigraphic unit. So the high TOC is concept A, the lithostrat unit is concept B. Then in another document, there was mention of this lithostrat unit, concept B, and then an age, which is concept C. But in this quite large, several thousand documents, it was never stated that there was effectively a lower Cretaceous potential source rock. But you could infer that through the ABC type rule. And these techniques have been around for quite a while. There's a nice study where links between Raynaud's disease and fish oil, and also magnesium deficiency and migraines, was actually predicted in a same ABC type technique. Literature-based discovery is one way to call it. And these were never explicitly stated, but the knowledge was there, latent within the text, almost again hiding in plain sight. And they were later proved empirically. And there's many other examples that if we put all our text together, there's the potential for new business and scientific discoveries if we know how to look.
So that's the grand challenge, and that's the grand benefit you can get from this. Let's, in the few minutes that are left, let's talk now about what people and companies should do concretely to benefit from this. So one question is what should an oil and gas company do in order to discover new important information from the mass of textual data and documents they hold? Another part of the question is, what should an oil and gas professional learn? What are the courses and resources, et cetera, they need to go? And then we have an audience question, which is the biggest challenge for a PhD student is data. Can you please explain where we can get subsurface data? So can you address, these three aspects, the learning, access to the data, and what a company should do in whichever order you want?
Right. Okay. Yeah, that's a bit of a memory challenge. I think, for some companies, it's making sure you've got like a text lake of your unstructured text NLP ready, so you can apply as many algorithms as many times to it as you like. So remove any barriers to iterations. I think, one thing that I sometimes observe is, it's difficult to the more iterations that you can do, the better the result you'll get. So you want to try and remove barriers to that, and think of having an environment where you might have a traditional search index which is document focused. You might have a statistical language model which is corpus focused, and thirdly you may have a knowledge graph which is more concept focus, and you put those three together and they support a whole variety of how you might interrogate information. I also think, maybe slightly controversial, but data scientists really have no idea whether the output from an NLP project is valuable to the business. So the challenge is to bring in those geoscientists, engineers, commercial analysts, managers, and other business people to be as close to this environment and get that iteration going, the time invested to it. If it becomes a bit of a batch process, then you're likely to get, quite suboptimal approaches. And I will also say, Agile is supposed to encourage this, but we shouldn't frame projects to an inch of their life. Sometimes we're afraid to admit it, but a lot of the best discoveries are somewhat accidental or unexpected. So, we just need to experiment and go in with some loose framing, and then, see what emerges. And, quite often what you end up finding and what's valuable is quite different to what you started with. In terms of training, people learn in different ways. I bought a bunch of Python books and I never opened them because there's so much of information on the available on the internet. My style of learning is learn by doing. So, write something that doesn't work, find out why it doesn't work, and learn that way. Other people have sort of different styles, but there is a host of online. I wouldn't necessarily recommend any particular one. I think there's a lot of good courses if you do some searches for that. I'm trying to think what else, Claude, have I not answered?
So how does a PhD student who's doing some research, how does he get the data, or how does she get the data?
Well, there's been a lot of public data put into the public domain. The Volve dataset in Norway, for example, contains both data and documents. Is an excellent example of lots of well files and information. Increasingly, national data repositories are actually making the information in the government's licensing rounds sort of available. There are public sources, geological surveys are making their information available. It is a bit challenging in the oil and gas compared to, say, the medical sector, where you've got PubMed, where a lot of the medical literature is sponsored by governments, so it's all released into public domain. And there is still quite a lot of geoscience and engineering information behind sort of paid firewalls. But there's still quite a bit out there, public sets if you dig around. And if anyone, I can send some references after. People feel free to contact me to get yourself going.
So we've got several other questions that have come in, and we're not going to have time to take all the questions. So I think we can certainly look at channeling this dialogue farther. There's a question about the potential for transfer learning. There's one about training bias and how we mitigate the training bias, especially in the oil and gas domain. And there's a question about the quality of data, of course, which is a prevalent thing. So we're going to have to sort of move on to the conclusion very, very quickly. But I just rattled off several topics. Do you have a quick comment on those, Paul?
Yeah, sometimes you've got what you've got. So if you've got scanned documents, then you need to adapt your NLP to cope with the fact there'll be a lot of mistakes in the text. I think things like language models, statistical models, they're a breakthrough. They are a big piece in the puzzle, but they're not the whole jigsaw, and they don't work in a lot of different contexts. So don't go in, I must use this method to address these particular problems. Think. I would suggest think quite broadly. A bias is obviously intrinsic in almost everything we do. We can actually use NLP to help us with bias. We can look at all our proposals and plans and maybe the sentiment in those, and then compare them with what actually happened, and reveal systemic biases in the way our organization or maybe thinks. So I think as long as you're aware, that's the first step to catering with any bias. But your training set has to be as close as possible to the information that you're going to apply it to, and that's obviously something to bear in mind if you've got models based on movie reviews or internet content, and you're applying it to very technical information. Having said that, I've used plenty of generic models, and they've performed pretty good against some pretty messy drilling reports, for example.
All right, so we could certainly go on for probably another hour if we had the time, but unfortunately we don't have the time. Do you have any final words of wisdom that you would like to leave us with?
Well, I don't know about words of wisdom, but I would say, sometimes, in amongst all this text, to see the meaningful, you have to remove the obvious.
Wow, that's profoundly philosophical. Thank you. That was a great final statement. So that's all we have time for today. Thank you so much for your insights. I think this was absolutely fascinating, and it's amazing that you wrote that back in November, and then since then we've only been hearing about ChatGPT every day. So it's clear that you're at the top of this trend and making it useful for our industry. I can only add a recommendation that everyone go and read Paul's article, which was in the December 2022 issue, again, of the DSEA Technical Section newsletter. As a reminder, the title of Paul's paper was Natural Language Processing in the Subsurface and Wells Disciplines, and it starts on page 5 of that issue after the sort of initial preliminaries. Thank you for joining us today, Paul, and thank you for our audience for having joined us, and we'll see you next time.
Thank you, Claude. Thanks, everybody. Bye-bye.
Bye, everyone.
Thanks for listening to the SPE Live podcast. For more content, visit the SPE Energy Stream, the industry's digital pulse, at streaming.spe.org. If you enjoyed today's show, don't forget to subscribe and review. Join us next time on the SPE Live podcast.